Hi everyone, welcome back to my YouTube channel, and this is Manas, and today I am going to discuss the third problem of recent edu round of Codeforces. So let's just start the video. At first we'll try to understand the problem statement, and after that I'll break down the solution into three parts. And first part is intuition, second part is the, you can say, that brute force solution, and then we'll optimize that solution using segmentary. Okay, and let's just understand the problem statement first. And uh, you are given one permutation, basically permutation of length n, and that permutation is not in, like, that permutation can be in any order. Okay, and there are two friends, Alice and Bob, and they were trying to, like, they are trying to play a game. Okay, let's just take one example, this example 2 1, just a second. 2 1 4 3. Here this is the permutation of length 4. Okay, and Alice and Bob, like, they are two friends, and they are trying to play a game, and the game has some rule, and the rules of the game are, in this game, Allies first make a move, and then Bob will make a move, and then Allies, then Bob, in this way. And in one move, let's if in one move, what are the possible option, like, you can do here? In one move you have to choose in, like, see, at first Allies will make a move, so Allies can choose any random number here. He can choose 4. 4 means third index. Okay, and after that Bob has to choose a number which is less than the number of, less than the number chosen by Alice. Okay, and also that number should exist left of the left side of the Alice chosen number. Okay, these are the two conditions. And after that, let's just Bob choose this number. Mm, Here if we have 3, and here just okay, so just a second, I'll give one example to understand the problem statement. So here consider 3 2 3 4 1. Okay, let at first move, Alice choose this number, and then Bob, like, what are the possible number for Bob is 2 and 3. Why? Like, if Allies choose one number, then Bob can choose a number which is less than the number chosen by Allies, and also that number should exist left side of the Allies chosen number. Okay, so these are the two conditions, and if these two conditions satisfied, then Bob can choose that number. Okay, and if any one of them is not able to make a move, let's suppose uh, in at certain point uh, Bob cannot make a move. Okay, and at that condition, if Bob cannot make a move, then at that condition Bob will win. Okay, so yeah, like, this is a little bit different, like, one is not able to make a move, but he's still able to win. And if Allies is not able to make a move, then Allies will win. And this is the problem statement. Okay, so if someone is choose a number, and the next one can choose the number if the number satisfy these two conditions. Okay, and the condition, what are the condition I have told you. And here, like, this is the game rule. Okay, and what you have to do is, you have to tell what are the possible number, because what are the possible position for, sorry, what are the possible, how many possible position exist for Allies, because allies will make the first move. Okay, and what are the possible position exist for Allies, so that Allies will win the game. And if Allies start at that position, no matter what, no matter what move Bob will make, but Bob will lose and allies will win. Okay, so this is the condition. I mean, sorry, like this you have to say this. You have to told what are the possible position, so that if allies start from that position, the game allies start the game from that position. What are the possible position? If allies start the game from that position, no matter how the ball will play the game, allies will win at the end. So you have to uh, answer the how many number of index exist. Okay, so this is the problem statement, and I hope you understand the problem statement. And as I said previously, uh, we'll divide the problem solution of this problem into three part. First part is intuition, and you can say, like, you can see here the constant of the problem here n. The value of n is 10 to the power 5, so we have to just think like order of n or order of n log n solution. And yeah, so first, like, see, like, there are three rules to solve a problem in my, like, what I did. Like, uh, if you give a problem to me, then how I approach the problem is that I just read the problem statement carefully, understand the problem, and then I watch the constant and what are the possible solution exist. Should I able to should I write a algorithm order of n or linear or n log n n square? So then I observe the what are the possible solution I can write, or what are the possible algorithm, uh, timely algorithm that I can write. And after that, I'll try to make some observation. Like, this is the most important thing. Yeah, like, observations things are, will, like, if you solve a brute force problem or a simple recursion problem, then you don't need like much observation. But in the kind of optimization problem, you need much observation, and observation will help you to optimize the problem statement. Okay. And okay, so like, we'll discuss how to approach the problem in separate video. And in this video, we'll discuss the problem only, the solution of this problem only. And just take one, like, just observe one thing. See, one, in I think in this example you will know what I'm trying to say. 1 2 3 4 5, this is the 5 length permutation. And the permutation is like in this order: 1 2. Permutation can be any order. This is not like increasing or decreasing order, it can be any order. And 1 2 3 4 5. Okay. And in this case, uh, if Alyssa start at fourth position, then can Alyssa win the game? If he start from, okay, let's just number this permutation. This is first position, this is second position, this is third, this is fourth position, this is fifth position. And just have a look, like, if Alyssa start from fourth position, can he win the game? No. Why? If allies start from fourth position, then Bob can choose any number which is less than 4 and also exist left side of the number 4. And here there are there are three element exist which satisfy the given, which satisfy the condition that the number are less than 4 and also exist left side of the fourth index number. So Bob, like, see, Lisa will try to make, in this case both the player play optimally and each player try to win the game. Okay. And Bob, like, after making a move, Bob try, like, what will Bob try? Bob try to win the game, and the winning condition of the game is if someone will not able to make a move, then that person will win. Okay, so this is the winning condition of the game. And in this case, Bob tried to win the match, and for that he will come to the second position and choose the second position element. He'll not try to choose the fast position element, because if he choose fast position element, then Alisa cannot make any further move and Alisa will win. So he just came to second index. He just come to, sorry, he will come to second index and choose this second index element. And after that, Alisa have only one possibility, and like Alisa forced to choose the fast index. I mean, like if you have any move, then you have to make move. You have to make that move. Okay. So in this case, Alisa have only single move, and Alisa Alisa have to choose this. Alisa have to choose the fast position element, and after that, Bob has Bob has no Bob has not any possible move. So in this way, Bob will win the match. And what you have observed from this, like what you have observed from this example, and I what I observed is that you have to choose an index. From that index, like see, here in problem statement, we like in our answer we have to tell that what are the number of possible index, what are the number of possible index where Alisa can start to win the uh, match. And Alisa will try to start from those index. From those index, we have only one possible move to go backward direction, to go left side. Okay. So from that index, if we have let's suppose Alisa will choose x index, and from x index we have only one possible move. And that, like if we have only one possible move, then Bob have to make move. Like obviously we have some moves, then we are bound to make that move. Okay. So in that case, Bob will bound to make that move, and after that Alisa has no move. So Alisa will win the match. So this is the intuition, or this is the observation for this problem. So Alisa will choose those index. From those index will have only one possible move. Okay, only one, and not more than one. So in this way, like yeah, like this is the intuition, and how we can find those index. That is the solution. And see, at first I'm going to discuss the brute force solution, like 2-3 minutes you can understand the solution, and then just like simple optimization using segmented. That okay. So so let's just take the above example, the last example, that is 214 if I am at this index, then can I make any move? So here in this case, I just try to find possible moves for each index. Okay. And possible moves for each index, and if the possible moves is equal to 2, then I'll increase my answer. So what is the possible moves for the fast index? What is the first like yeah, like what is the possible moves for, if I choose the fast index, then I cannot make any further move. So for just do this thing. Also we have to well, also we have to keep in mind one thing, that the number, yeah, like see, for the 2, if I choose the number 2, then I cannot move anywhere. So 1 2 3 5. Okay. So for 2, let's just uh, put an, this is like this array will indicate the possible move or moves. You can like, yeah, like keep this array name is moves for each index. moves moves. Okay. And for 2, there is only one move. I can for 2, from 2 there is no moves, but I can go to 2 na. I can go to this position, first position where 2 exists. So uh, for that I take possible moves for 2 is 1, and from 1 what are the possible moves? If I choose 1, then from 1 can I able to, can I go anywhere? Nah, sorry, no. I mean, why? For from 1 there exists only one index, leftward direction, because 1 is in second position. So we have to set, like, the moves should be satisfy, the moves should satisfy two conditions. That move is exist in left of the recent moves, and also the value at that index should be less than the value of the previous indexed value. Okay, and here there exists only one element from the left of the one, and also this value is greater than one. So yeah, like we cannot go to this first position. For 1 also the answer is 1. And for 4, see, from 4 I can go to 1, or I can go to 2. But it's not like from 4 you have to go to 1, and from 1 you cannot go anywhere, because from 1 the answer is 1. That means you cannot make any further move. Or for better understanding, you just took this thing as 0. From 1 I cannot go anywhere, from 2 I cannot go anywhere. For 4 I can go to this place. Okay, and so the number of moves is 1, because from 4 if I go to the second position element, but from 1 to I can go not like I cannot go anywhere. And if I, like, if from 4 to, like, from 4 if I go to the first position element, then from this position I cannot go anywhere. So for that, for this region, the possible moves for 4 is 1. I mean, from 4 I can move to 1 or 2, or you can say that from third position element to I can go to any one of the element. Or yeah, like I can go to, no, no. And for 3 what are the possible moves? For 3, just go backward, just go backward direction or left direction. Is this value greater than equal to, no, sorry, is this value less than equal to, is this value less than equal to 3? No. Is this value less than equal to 3? Yes. And is this value less than equal to 3? Yes. And just write, like, see, from this place I cannot make any move. For this the answer is 0. And just add 1, because from 3 to I can move to 1. So for 1 is 0, but this is one move na, from 3 to 1. So for that I have to add 1 in my answer. For 3, for 2, yeah, like for 3 1 it is 1, and for 4 it is 1. uh, why I am like writing this dp of, sorry, moves of this index, like this is 1, moves of 1 plus, moves of this plus 1, and moves of 1 is here 0, and this is 1. So from 3 to I can move to 1 position element. And here, yeah, like, see, from calculating, if we want to calculate the answer for a given position element, then we have to uh, traverse from that position element to zeroth element. This is happening. So that will lead to the time complexity n square, and we have to reduce this time complexity. And also notice one thing, that for for like, so why, like, you guys can say me, like, you guys can ask me why you are using here max segmentary, because I have to show one condition. In that condition you can just, like, see, here if I started move from 3, then I have to come to, I have to check for all the index which is less than, all the index value which is less than 3. and this value is less than 3, this value is less than 3. So I have to take what is the possible moves for this value. This is 0. Okay, what is the possible moves for this value? This is also 0. So I have to take the max of these moves and plus 1, adding plus 1, and whatever the result will get, that is my answer for, that will be my answer for 3. And why I am taking the max? Okay, uh, let me just give one example that yeah, like this is one of the case you have to observe. Why I am taking, I am going to observe, sorry, why I am going to take one. So see, let's just take one condition. This is for 5. This value is this is 4, and this is 1, this is 3. Hmm. And here we have 2. Yeah, see, if I build the moves array or moves vector for 4, this is 1 2 3 4 5. For 4 the answer is 0, because from 4 I cannot go anywhere. For 1 also again the answer is 0, because from 1 I cannot go anywhere. For 3 the answer is 1, because from 3 I can go to 1. So for the answer is 1. And for 5, what is the answer? For 5, what is the answer? This will like help you to understand why I am taking. For from 5 I can go to 3. Go to 3 or not? Yeah, I can go to 3. And from 5 I can go to 1. 1 or not? Yes, I can go to 1. From 5 I can go to 4. So but from 4 I cannot go anywhere. But from from 1 I cannot go anywhere. So here the number of possible moves for 5 is 1, because from 5 I can move to only one place. So you might think that okay, so for 5 the possible moves is 1. So yeah, like this can be one of my answer position. But no, like observe here, the from 5 I can go to 3. Not. So okay, if the allies is choose this 1 2 3 4 fourth index, then allies assume that okay, so yeah, I'll choose the fourth index, and I'll Bob have only one possibility, and he have to make that sorry mm, he has to he forced to go to that index, and I'll win the match. But this is not going to happen, because simultaneously Bob also trying to win the match. So in this case, what the Bob will do is, if allies choose the 5, then Bob choose 3, and from 3 I can go to one position. Understand or not? Then Alicia will force to uh, Alicia is forced by Bob to make move. Alicia is forced. Yeah, Alicia is forced by Bob to make. Alicia is forced by Bob to make one move. Okay, and yeah, like in this way, Bob will win the match. So that's why I am taking the max. Although this is 0, but this is 1. This is 1 means Bob select this index, and Bob forced Alicia to lose the game. So if we took max value, then that is your, like, from this person the value is 1, and the max plus 1 is 2. And after making this for 2 the value is, I can go to only move to 1. So for the 2 for the 2 also the answer is 1. And after building this array, I just have to count the number of uh, I just have to count the 1 present in this array. Okay, so yeah, like this is the solution. And why I took max. I think you guys understand this thing. And see, the time complexity of the solution is what? Time complexity of the solution is n square, because every time I have to traverse from the recent index to zeroth index. So that's why I have to reduce the time complexity, and to reduce that time complexity I used segment tree. And how the segment tree will going to help you, and that right now I'm going to discuss that. And see, mm, for a particular index, how we are calculating index from particular index. I just have to, like for 5, what are the possible position value that I can reach, 1 to 4, 1 to 4 or not. Yeah, so I just have to find the uh, maximum value from 1 to 4, and just adding plus 1. This is maximum value for 1 to 4, and we just have to add 1, add 1 in it, and uh, and that will be my answer for the current value. Current value here, the current value is 5. So yeah, like I think if you understand the brute force solution, then you can, like, if you know like how to implement segmentary, or how the segmentary will work, and in which condition we apply segmentary, then I think you will uh, I think you might be able to think how the segment, like how we optimize this using segmentary. And also I gave I gave one hint that for a particular index, we don't have to traverse from that index to zeroth index to check all possible values. But we can query the value, like if the index is the value is x, then what is the maximum value between 1 to x minus 1, and just add 1 in it, and that will become the answer for the current value. And similar way, uh, and after calculating the answer, don't forget to update in segmentary. And like for that, basically you need a dynamic segmentary. Yeah. And yeah, like that you will, after calculating answer for all the index, you just have to count the number of 1 present in it. Yeah. And yeah, I think this is the solution. At first build the segmentary, just put all the values 0 in it, 0 0 0 0, and just find just query the value from 1 to x minus 1, what is the maximum value, and you'll get some value. And for in that value you just have to add 1 in that value, and 1 in that value, and that will be the answer for your current indexed value. Yeah. And after that, update your current indexed value in uh, like don't yeah, like you have to update in your segmentary and update. And yeah, like similarly you have to find answer for all the index. And after calculating answer for all the index after calculating answer for all the index, just count number of 1 in it, and that will be our required answer. So let's just discuss the time complexity of this solution. Time complexity of the solution will be n into log n, because for every index, for a like say, building the segmentary time complexity is order of n. But if we want to make any update or query the value, then the time complexity for that is log of n. So for each index I am performing two operation. One operation is querying the value, and another one is update. So log of n plus log of n, 2 into log of n. This is for one index, and for n index the value is n into 2 log of n, and the space complexity will be order of n, and n for segment tree 2 into n, and yeah, like the space complexity is 2 into n and time complexity is n log n. This is the solution. And if I show my solution, if I show the solution, here I build the segment tree. I just take the input and here I build the segment tree, and after that I just here I query the value, and this value plus 1, this is my answer value, and then I update the things in tree and then count all. Here I am counting 2. Yeah, here why I am counting 2, because here uh, in my explanation I have told you to put 0 if you are not able to make an, like if you are not able to make any move from your current position, but here I am considering this is 1, so that's why I am counting 2. Sorry, yeah, like that's why I am counting 2. But you can you can count 1. Okay. And yeah, like this is the solution for the third problem. I think you might face any, like you might face issue in the segmentary part, but yeah, like if you have any issue, uh, just ask me in the comment section and I am happy to answer you. So thank you.